question number 9. It's about a probability. Guys, in probability, you will get a question like, using the formula, that addition formula to do some question, where events are there, mutually exclusive, like that. That long formula, probability of A union B, or A or B is equal to probability of A plus probability of B minus probability of A and B, if it is not mutually exclusive. If they are mutually exclusive, then probability of A or B is equal to probability of A plus probability of B. That type of questions are there. Then questions using tree diagrams, you can get it. Questions using Venn diagram, you can get it. Then questions using contingency table. So in this question, we are using only a tree diagram and a contingency table. Okay, using that we have to find a probability of certain events. That's how it is. Okay, we can do these questions very fast. A packet of sweets contain 3 pink, 2 greens and 5 blue sweets. So altogether, how many 10 sweets are there, where 3 of them are pink, 2 of them are green and 5 of them are blue sweets. Okay, so altogether 10 sweets are there. So 10 is the sample space, isn't it? Yes. Then you have to pick 2 sweets removed in succession from the packet without replacement. Without replacement means you take one, then that first one will not go back. You have to take the second one. Okay, so when you go for the second one, you can see the sample space is reduced by 1 because the first one did not go back. So that must be there in your mind. Okay, so this one is dependent, not independent. It is dependent actually. Okay, it is not a independent event. This is dependent because the sample space are affected when you go for the second switch. All right, now you have to draw a tree diagram. So here the events are, you are picking up how many sweets? 2 sweets are there. So you are not taking 2 seats at a time. You are taking, even if you take 2 seats, you have to consider one by one. So let me start with the first sweet. If I take a 1 sweet randomly, so it can be, so always when you do a tree diagram, it has to start from a point. 9.1 is a point. That first sweet can be pink one, so 1 branch for P, or that first sweet can be a green one, so one branch for green. Then that first sweet can be a blue one, so it can be blue. So this, the one that I did now is for the first sweet. Okay, not the second sweet is following. Okay, it follows. This one is the first sweet. We are done. So on those branches, please write the probability. Out of 10, how many possible pink sweets are there? 3 of that is 3 over 10 for the pink. Clear? Because if you are selecting only 1 pink, don't write 1 over 10, that is wrong. That 1 pink can be any one of that 3. So the favorable outcome is 3. It can be P1 or P2 or P3. So 3 divided by total 10. That's how you have to do it. Then when it goes to green, it's going to be 2 over 10. I think it is clear now. Then blue means 5 over 10. Remember, the one that I did is the first sweet. Okay, we are done with the first sweet. Now I am going to do the second one. Always consider the first one, okay? Then move to the second one. That's how the possibilities. So the first, I'm going to fill up the possibilities. Look at here. Along the first branch, that is P. What does this mean? If the first one that I selected is pink, then second one can be any one of this. Did you see that one? It can be pink again, or green, or blue. Is it clear now? This is how. First one is pink, then second one is any one of these, guys. Any one of this. This is one of the possibilities. So how do you fill that probability? First one is pink. Already pink is selected. Then if you get a second one pink, means how many pink are there remaining there? favorable one, only 2 of them, because you selected one already, it did not go back. Divide by, since the first one did not go back, what is the sample space? 9, guys. Is it clear? Don't write 10. Okay, if it is with the replacement, then that one is going to be again 3 by 10, because first one has to go back. So sample space is still 10, then pink is still 3. But here without replacement means when you go for the second one, it can only 2 of them are remaining there out of 3. Clear? Then green, what will happen? Because first one is pink, so all greens are there. So how many green? 2 over 9. Isn't it? Alright. Then blue also, same story. All 5 blues, so that is 5 over 9. Clear? This is how it is. So, each brush, see this one, the total must be 1. You can see that when you add it. That's how the story is. And here, another full branch we got it. This total must be 1. Is it correct? 2 over 9 plus 2 over 9 plus 5 over 9 is what? 9 over 9. You understand? Which means our workings are correct. So I am done with the one possibility where first one is a pink, then second one any one of that. Then another possibility. First one is a green, then second one can be what? It can be pink, it can be green, it can be blue. Another possibility, okay? First one is green, then second one can be pink. How many pink are there? Because first one is green, then pink 3 of them are there. 3 over 9, because first green did not go back. Then green, already we selected 1, then what is left there? 1 over 9. 1 over 9, because already you took 1 there. Then blue, still all of them are there because first one was green. So blue, how many? 5 over 9. Is it correct? 3 plus 1 plus 3 is going to be 9. Okay, it's correct. Alright, now another possibility is, what if first one is blue, then second one can be what? Pink, green, blue. If first one is blue, then second one pink is 3 over 9. Still sample space is 9. Don't write 10 there. First one is blue, second one green is 2 over 9. Then first one is blue, second one also blue, means how many blues are left there? 4 over 9. Is it clear? So this is how you have to fill the tree diagram. 6 marks question. Easily you can do it. Alright, now we can go to question number 9.2. 9.2.1. Now you are finding the probability based on tree diagram. Okay, along the branches you have to multiply, between branches you have to add them. That's it. This is the starting point. This is starting point, and these are the finishing points. Okay, always you have to consider like that. These are the finishing points. Clear? Yeah. So both sweets are blue. Both sweets are blue means starting point here along the branch, first blue and second blue. Did you see that one? So along the branch I cover 5 over 10 and 4 over 10. So probability of both of them are blue. B is equal to 5 over 10 times 4 over 9. The one that you cover, all of them you have to multiply. That is, it's going to be what? 20 over 90. This is how, or you can change it into decimal. So this is how we do that question. Then 9.2.2, what? A green and a pink sweet are selected. They didn't say first one is green, second one pink, like that. It can be any order. So out of 2 sweets, one must be green, other one must be pink. So green and pink, how many combinations are there? See guys, starting point, we can take this one, green and pink. Do you see that? Then pink, this one, pink and green also you have to consider. Is it clear? So 2 combinations are there. So it is going to end here. This branch you have to select, and this branch also. So between branches means you have to add it. So along the branch, that is P and G, what is that? 3 over 10 times 2 over 9. I'm talking about this branch. Starting point up until there. Along the branch I multiplied. Now I'm going to take the next branch. What is that? this one and this one, isn't it? Sorry, this one and yes, same thing, this one. So you have to add because you are going to the next branch. So again along the branch, that is 2 over 10 times, just a minute, 2 over 10 times 3 over 9 times 3 over 9. So what is the final answer? 6 over 90 plus 6 over 90, isn't it? So the answer is 12 over 90, or you can change it into decimal, 0,133, you will get it. So this is how we do it. Okay, so tree diagram, it's all about how to make the diagram. You know, this diagram, tree diagram, contingency table, and it's all about how you create that one. Venn diagram, once it is there, Venn diagram completely, you fill up all the numbers. Then probability questions based on the diagrams are very simple, but your diagrams must be correct. Okay, then we can get it all the answers correctly. Is it clear? Now we can move to 9.3. It's about the contingency table. Let me rub this one. All right, 9.3. A survey was conducted amongst 60 boys and 60 girls in a grade 8 relating to their participation in sports. 20 girls did not participate in any sport, and 50 boys did participate in sports. Complete 2 ways contingency table for the above survey. So here, how many things are there? Boys and girls, 2 category, then sport and not sport, isn't it? So that's how you have to fill up that one. Let me write boys and girls, boys, then column wise sport and no sport. Okay, then this is the total. Now 60 boys and 60 girls, is it? Okay, then 20 girls did not participate. 20 girls did not, 20 here did not participate, which means participated how many? Altogether 60 means it's going to be 40, isn't it? 20 means 40. Now 50 boys did participate in a sport. 50 boys participate, this is 50, which means this is 10, isn't it? 10, because number of boys and girls, they are same, 60 and 60. So you have to see, the table was not given, you have to construct. This is how we have to construct. Now the total, column total and the row total, here also total. 40 plus 20 is going to be 60. 50 plus 10 is going to be 60. 40 plus 50 is going to be 90. 20 plus 10 is going to be 30. So the grand total is what? 120. Clear? That is a sample space. So we are done with the table. Now one by one we can do. This is 5 marks question. Then 9.3.2. What is that? A learner is chosen at random. They didn't specify which gender. A people is chosen at random. It is a girl and participates in sports. It is a girl and participates in sports means how many girls are there? 40 girls. So answer to the first one is 40 over 120. Okay, done. Or 1 over 3. We can simplify that, 1 over 3. Got it. Then next one, 1 mark question, that is, this is A, this is B. What is that? A people does not participate in sport and is not a female. Not a female does not participate, which means a boy participate no sport. It's going to be how many? 10, isn't it? So 10 of them are there. So the answer is 10 over 120, which is equal to 1 over 12. So this is how we do it. We are done. So guys, this is how we do questions from probability. Okay, I hope you understood. Thank you.